I'm Tim Ventura from American Antigravity, and I'm speaking today with Frank Zdnidarsic, a pioneer in gravity modification research and one of the early investigators of Podkletnov's rotating disk experiment in the 1990s. Well, Frank, I'd like to start out by asking a bit about your background and how that led you into the experiments with Podkletnov and NASA in the 1990s.
Well, thank you, Tim, for inviting me on your show, and it's a pleasure to be here with you, and I appreciate your efforts in this area. How I got interested in this work originally is I'm an electrical engineer, and I worked in the energy fields. I worked in coal, I worked in power generation, and I saw the environmental damage that was done by these resources and the limited finite nature of these fossil fuels. And I realized as our population increases and our population has become increasingly dependent on energy for transportation, for food, for making ammonia, for fertilizers, and I felt there must be a better way to produce energy and possibly get us off the planet to harvest natural resources from beyond the bounds of the Earth. And so that was my motivation.
Oh, okay. Now, this has led you to a new book that you've just published entitled Energy, Cold Fusion, and Antigravity. And so that really describes your current research. I'm wondering if you could tell me a little bit about that book and what led you down the path towards writing it.
What I was interested in is control of the other forces beyond electromagnetism. Control of the electric and the magnetic field to produce this marvelous age that we live in. And the reason we can use the electromagnetic force, it has a convenient range and strength. For instance, if you hold a magnet in your hand, it'll pick up some metal fragments. That magnet also has a gravitational field, but it won't pick up anything because the gravitational force produced by something you can hold in your hand is far too weak. And there did not appear a way to harness that. And that's what I studied. Is there a way to increase the strength of the local gravitational field? And that's basically what I got in my book, some of my ideas on that subject.
You're just referring to the fact that gravity is so many orders of magnitude weaker than the electromagnetic force is, right?
Yes, gravity has the same effect as electromagnetism in some ways. It radiates outwards. It's called a field that diverges outward and affects material things. And electromagnetism reaches out and only affects charged particles. But the gravitational field is 10 to the 39th power weaker than the electromagnetic field. So we know what to do with the electromagnetic field. We can spin it in a generator to make electricity, put it in a speaker. You're hearing my voice through a speaker. There's a magnet in there. We know what to do with that electromagnetism. As a matter of fact, the phone lines that are connecting us up enable this conversation. There's electromagnetism in there. We can control it. We can vector it. But gravity is so weak that we can't even detect changes of it unless it involves a mass of the entire Earth. Now imagine a magnet as strong as the entire Earth, as big as the Earth. We'd be like stuck, pulled down with tremendous force. So gravity's been weak, and current theory holds that it will remain weak at all times.
Now, it sounds like there are a couple of challenges there. That one of the big ones is amplifying it, but the other one is coupling to it in the first place. And one of the things that you've really gone towards is gravitomagnetism as a method of coupling to gravity. Can you tell me a little bit about what that is, how it potentially couples, and what led you to that as a mechanism?
Yes. Okay, religion has laws, 10 commandments, and you can violate these laws and you will pay the consequences. Well, science has a similar set of laws. They're called the conservation laws, the conservation of energy, conservation of momentum. And these laws cannot be violated. You can't violate and pay the consequences later. They're like impenetrable. And so we have to look within the conservation laws to see what's possible. With electromagnetism, the electric field is very weak. Too, you can rub a balloon on your head and stick it on a wall, but the force is feeble. Or you rub a cloth in amber and it'll pick up some dust, but you can't do much with it. When you move an electric field, it produces a magnetic field, and that's sort of weak too. If you got a balloon, rubbed it on your head, then moved it past something, you wouldn't get much magnetism. But magnetism is not a conserved property of the universe. You can get more of it. And so when you have an electromagnet, it's a coil, it's very weak, but you put some soft iron in that coil, and it magnifies the electromagnetism, the magnetic component of it, by a factor of 10,000 or more. So that shows us that it is possible to amplify the magnetic component of the electromagnetic field and the magnetic component of all of the force fields are not conserved. And so if we had the right material, it wouldn't necessarily be soft iron. There should be something out there that may be able to amplify the magnetic component of the gravitomagnetic field. And then we would have a very strong gravitomagnet. It would have the same structure as an electromagnet. It would curl around from in and out from one pole to another, but it would affect everything, not just charged particles. It would have an effect on all of matter. And just as Faraday, with his original experiments using amber and making a static charge, could not predict that the control of electromagnetism would lead us to modern computers, I cannot envision where the control of gravitomagnetism will take us, but I'm sure it'll be equally as astounding.
Yeah, and that explains both the coupling, the choice of gravitomagnetism, as well as the amplification, because you're saying that since magnetism isn't a conserved force, you can make these incredibly large fields, but they also couple to gravity, and this is an area where I believe there's a lot of ongoing research.
Yeah, you can't have a gravitational shield, because if you had a gravitational shield, everything above that shield would fly away. So the moon would be above it, it would fly away, and the whole galaxy and a billion stars. So obviously you've made a gravitational shield. It better have enough energy in that shield to move about half the universe, and that's clearly impossible. Gravitational shielding is impossible, and that's what Podkletnov said he had, but I think he misinterpreted. I think he had a gravitomagnetic field, and a magnetic field is a local field. A magnet will, pull on stuff for a certain range, and it doesn't pull anymore. So you only have to put enough energy in a gravitomagnetic field to infect the local environment. So it's possible. I think he did it.
Oh, okay. Well, now speaking of Podkletnov, I understand that NASA had difficulty replicating his original disk experiment, and I think that was something that you were part of in some small way, but I understand that they only were able to achieve a small percentage of the rotational speed that he originally claimed to see the effect at.
Well, they didn't really replicate his experiment. I was down there. They invited me to witness their experiments. That would be Lot Brantley. I met David Noever down there and had some discussions with him, and Glenn Robertson. He and I followed through on that and recently published a paper, peer-reviewed paper on this. But what Podkletnov did was rotated a superconducting disk. It had multiple layers, and I'm not sure what the layers had to do with it, and he exposed it to a radio frequency wave. They never completed the experiment with exposing the disk to the radio frequency wave. Now, what I found amazing, what interested me, was that the frequency of the radio wave, and it was about 3 megahertz, and the diameter of the disk was 1/3 of a meter. So I took the 3 megahertz radio wave, multiplied it by 1/3 of a meter, and I got a velocity of about 1 million meters per second. I didn't know what it was, but I thought that was something interesting. It should be important. I had that intuition that it was important, but at that time, I didn't know what it was, and their funding was cut before they could duplicate that portion of the experiment.
Now, were you able to find out what that was in the meantime?
Well, what happened about the same time as I went to Anaheim, and I saw James Patterson and his Clean Energy Technology Cell, and they were producing energy. And this cold fusion experiment has a positive temperature coefficient. It means the hotter that it gets, the more energy it produced. And thermal heat has a vibration to it, or a frequency to it, in the infrared band, about 10 to the 13 hertz. And also these things were occurring in the domain of about 50 nanometers. So I multiplied the thermal frequency times the domain side, and I got the same velocity, 1 million meters per second, that I saw in Podkletnov's experiment. So now we have 2 vastly different experiments, one involving gravitational modification with the superconductive disk, and one involving low-level nuclear reactions that exhibited the same velocity. And when I saw that, I said, there's something going on here. I felt it was of fundamental importance.
Yeah. Well, what did it end up becoming? Are you able to talk about that at all?
Oh, yes, absolutely. And that's what I did in my book. And that has to do with one of the greatest mysteries ever, and that has to do with the quantum lumpiness of the world. For instance, if you're going in your car and you want to go a little faster, you push your speedometer. You can go 10 miles an hour faster, 1 mile an hour faster, a tenth of a mile an hour faster. If you go to your faucet, you could turn it on full. You could tweak it, any flow you want. But in this quantum world, it's lumpy. You can only have certain speeds. The electrons orbit the atom in certain speeds. It's like if you're going down the road in your car and you push your accelerator and you're going 10, you want to go 15, and you jump to 20. You can't get to 15. Why? Why does this quantum world have this jump to it? And nobody really knew. Planck wondered about this, and from the very beginning, why is it jumpy? And the current chain of thought is that the quantum world is the true world, and this classical world that we live is only like an illusion. And our brain that's wired to understand the classical world, we really can't understand the quantum because it'll always be mystical. And I never really believed that. And what I saw in these experiments led me to a solution to that problem.
It sounds like, from what you've described, you're really a supporter of the idea, I guess, that Podkletnov saw something unique and that it wasn't just a measurement error. Would that be fair to say?
Yes, that is definitely fair to say that I believe he saw something unique. But some of his claims have been extreme, that he's doing things faster than the speed of light and he's smashing bricks. And these extreme claims that he's made recently puts a shadow on his credibility.
Yeah, that makes sense. But that original experiment, I think, that's kind of the one that you lean towards.
Yes. Well, what I found out is that velocity of 1 million meters per second, that is the velocity of sound in the nucleus. And what I did was I set the velocity of sound in the nucleus equal to the velocity of light in the electronic structure of the atom. And that means a mechanical wave equals the speed of an electrical wave. And I got all these quantum jumps. I got the spectrum of the hydrogen atom from that analysis, from a classical analysis. When I set them to equal, that equal sign says that the sound of a mechanical wave equals the sound of an electrical wave. And so for those waves to propagate at the same velocity, the forces that mediate them has to equalize. So during that quantum jump, the gravitomagnetic force acts strongly and at range, and the electromagnetic force acts normally, and the nuclear forces act at a longer range and at a reduced strength. So I was able to understand the quantum jump. And what he's doing when he's spinning this disk, he's putting the whole thing into a state of quantum transition. But it's very, very difficult because he has to induce this velocity of 1 million meters per second in the nuclear structure. And sound only propagates at 2,000 meters per second. So to get that vibration going at 1 million meters per second is quite a trick. And I think what they do in cold fusion is they have dissolved hydrogen atoms that they stimulate and can drive them. And in Podkletnov's experiment, he had light elements like hydrogen. It's called an optical photon. Sit there and vibrate. And by the radio wave stimulating them, they get them all to vibrate together, and the wave appeared to move at that frequency. That's what I'm thinking happened.
Oh, okay. Yeah, see, I was going to ask about that next. I was wondering if he was able to stimulate those radio frequencies further, if he might be able to get a more pronounced effect.
Absolutely. And you hit upon something. See, not everybody uses radio waves. It's possible to get that stimulation going with shock. And I worked with Eugene Podkletnov. We brought a group of us into Los Alamos, and he was using cavitation. And cavitation is like hitting something with a sledgehammer. And so for that very brief instant, you get a very strong impulse that tends to send that wave motion through the solid. And so that's another way of doing it. Podkletnov also followed through with his latest experiments with an impulse device where he hit the superconductor with a giant impulse of electromagnetic radiation that induced the wave motion by shock, not just by a radio wave. But there's other ways to do this.
Yeah, and it's possible also that maybe it was the combination of the radio waves and the rotation and all of that that set up a resonance.
Yeah, that's the key. You have to be able to get the atomic structure moving at the same velocity as the velocity of sound in the nucleus. And you have to set a resonance up, and you have to get the material just right, and you got to put the external stimulation. And when you do that, then some remarkable things start to happen. It's a situation of impedance matching. If I can explain it, when an electron jumps from state to state, it emits a single photon, not one photon and another one of less intensity, another one. If you bounce a ball on the floor, it bounces and bounces. You get several bursts of sound until it finally diminishes to nothing. But when one cue ball, one billiard ball hits another, the first one stops and the second one flies away. All of the energy is transferred in one step, so you get one spike of sound. And that's what's happening in the quantum transition. You get that one spike. It's an impedance match system. And that's why you got to match the velocity of the vibrations in the superconductive structure to the speed of sound in the nucleus. When those two speed matches, it allows a smooth transfer of energy between systems. And the energy flows from the gravitational system to the electromagnetic system, produces nuclear transmutations, and induces under the right conditions, a strong gravitomagnetic field.
Oh, okay. It sounds like you might be able to actually make this work without any rotation at all then, if you were just able to find what those ultimate resonant frequencies are.
Yes, hopefully you could, but there is a lot I don't know. I'm at the very fundamentals of it, looking at the mathematics. For instance, I have a 1925 radiola radio, and I have a Kindle Fire HD. If you look at both of them, they're completely different technology. One has great big triodes, and the other one has little parts you can't even see. But the mathematics that describes that motion is the same. And I'm trying to look at these systems and describe them mathematically, but I don't have the technology quite yet. It's another step. It's a lot more to do. The technology could emerge into a new computer someday, but I'm trying to get it into that first step, like that very first radio, just to demonstrate something.
Yeah, well, the reason I asked about that was I'd spoken to Tony Robertson quite a while ago, and he had talked about doing his own research into finding reliable methods to create the crystal structure in those large diameter YBCO disks that Podkletnov was using. And from what I understand, those are really difficult to replicate. It's a 12-inch disk, but Robertson had claimed that there was a crystal structure on the inside of it, and then the outside of it it was structurally a little bit different because of the sintering process. And he'd said that the first few of these that he made, and these aren't cheap to press by any means, the first few of them broke coming out of the press, and then he finally started getting results, but he was having trouble with it, even so.
Yes, to get one and spin it at that high velocity is quite an accomplishment because it's ceramic. It's like a flower pot. Try spinning a flower pot at 1,000 RPM. It'll be in pieces before you know it. And also he has layers in there. There's one layer, then another layer. It's not really understood what the layers do. I suspect that it opens up the structure to the stimulation so that it can respond mechanically to the applied electromagnetic radiation, but I don't really understand that part of it. There's a lot more work to be done.
Yeah. Now, in terms of superconductors behaving like kind of macroscale quantum particles or going through that quantum transition as you've described, I've read that this behavior or similar behavior is also observed in gas plasmas under certain conditions. And I was wondering, do you think that a gas plasma device might be possibly a replacement for the superconductors that were experimented with in the past?
I tried that, and I suspect that there is something going on with gas plasmas, and the manifestation of it is ball lightning. My father told me when he was a small child, lightning hit the chimney. At that time, they had a cook stove in the kitchen, and a ball of lightning came out. It looked like a 25-watt bulb. Came out of the cook stove and rolled across the floor and rolled out in the yard and went out in the garden and exploded. So there's something really, really, really strange about these balls of lightning. Where do they get the energy from? I know from an electrical engineer, once you turn the power off and you have a high-speed camera, that arc is extinguished within a tenth of a second or less. There's not much thermal storage in the air. So how does that ball of lightning continue to supply energy for seconds or minutes? It might be related, but I don't have enough information, and we don't always see balls of lightning. They're hard to find. They don't appear naturally in any circuits that we have now.
Yeah, that's an excellent point. The reason I'd asked about the gas plasmas is just because it seems like that technology might cost less and be easier to manufacture on a large scale.
Yes, when I'm presenting my way, many people have different ways. Ning Li said that we'd spin the nucleons up like a centrifuge to many more, get them spinning really fast, the nucleus in each atom, and that would produce the gravitomagnetic anomaly. I'm saying that if you put the whole state in a state of quantum transition by making the speed of sound in the nucleus equal to the speed of sound in the structure, that produces the gravitomagnetic anomaly. So many people have many ideas, and I think from an outside perspective, the verdict's still out. I believe I'm right, but I'm sure Ning Li believes she's right too. But how this is going to shake out, I don't really know.
Okay. I haven't heard anything mentioned about Ning Li in several years now. Do you know if she's still actively doing research?
I haven't heard anything either, but I'm quite sure if she would have been if something would have materialized from her work, that it would have reached the press. So things like an old soldier slowly fade away.
Yeah.
If there's no result.
Well, there was another result by Dr. Martin Timar and he had done a rotation experiment, and I believe that they used a marker, almost like you use a chalk mark on a flywheel, and they showed a very, very, very minute, what they believed to be kind of a warping of time-space that came from that. Have you heard about this experiment at all?
Yes, but in fact, I met Martin Timor at this SpaceIF, and he was there at my presentation. As a matter of fact, I have my lecture on the web, and Martin's introducing me. He's a very nice man. And he was had cryogenic helium in this device and spinning it and looking for anomalies with this optical gyroscope. And he detected some very small anomalies, but much, much larger than would be expected from general relativity, but too small to do anything with. And I asked him, did he apply radio waves and try to vibrate this material? And he said no. And he was at my lecture there, and I don't think that he followed my path. He's on his own path, and he got so far, and I think he's sort of stuck now. He's getting small anomalies, but he hasn't done anything useful.
Okay, so the radio waves might have an application there as well, and potentially, maybe his experiment in a negative sense is almost kind of like a proof of concept for the radio stimulation.
Yes, his gravitational anomaly is way larger than anything predicted by conventional theory, so it's an astounding accomplishment, but it's way too small to do anything useful. We can't propel a spacecraft off of it. We can barely detect it. So he's demonstrating a proof of concept, but I'm not familiar with the latest that he does, but I suspect that he hasn't moved beyond that stage.
Oh, okay. Well, one thing I should ask is, do you know if the way that you're looking at harnessing gravitomagnetism, is this a polarized phenomena? Like Ning Li had talked about an AC gravity, where you could do push or pull with it. And I guess one thing I'm wondering is, with potentially future experiments, do you know if this is something where you would only be able to create an anti-gravity effect, or potentially, create a stronger gravitational field as well?
I suspect what it's going to do is sort of like an electromagnetic force. It's going to tend to rotate things like a compass, but it's also going to tend to be expelled. So it'll be a repulsive force that generates also a twisting motion. Electromagnetism has two positive and negative charge. Gravity only occurs in one charge. So the gravitomagnetic field would sort of resemble the electromagnetic field of a neutron. It has no charge, but it comes out of one and circulates back into the other. And I suspect that it's generally going to be repulsive, so that we could repel off the atmosphere to get into space with the gravitomagnetic field. That's the kind of thing I'm looking at.
Yeah. Well, that's kind of how I envisioned it as well. I mean, what I've read about superconductors, quote unquote, shielding a magnetic field is obviously there's no way to shield a magnetic field in the true sense. But what they do is create an equal and opposite field because it induces a current inside, and that has the effect of negating that magnetic field. It constrains it. Do you think that this might do something similar with a gravitational field?
Well, see, you're getting into dielectrics. You put a dielectric between two plates, and it only reduces the strength of the original field. It can't make any more or make any less, but you put iron in the magnetic field, and it actually increases the magnetic field. And so if we could find this superconductor is the right stuff, the soft iron equivalent for gravitomagnetism, then it would increase the gravitomagnetic field. And that field will look like electromagnetic field. It'll curl around, but it'll have different properties. I know you've done experiments with your lifter, but the thing about the lifter is it has to repel off a charged surface. It can't repel off a neutral air. So once it gets away from the charged surface, it's sort of done with lifting. But if you made a gravitomagnetic field, it could repel off neutral air molecules. And so it could repel off the atmosphere in general and take us into space. And also, Einstein said there's this principle of equivalence, so that inertial mass is equivalent to gravitational mass. And once we start modifying gravitational mass, we may be able to reduce the inertial mass of a spacecraft and propel it promptly to the next star with conventional propulsion.
Oh, okay. Now,
that's a little more speculative. We have to get the gravitomagnetic field before we can do that, but that's in the line of possibility.
Yeah. Now, the other aspect of this is the low-energy nuclear reactions or the cold fusion. And one of the things that you'd indicated was that these same forces that allow you to couple gravity and magnetism may allow you to couple into the strong and weak nuclear forces, right, to be able to create these
Right. What I suspect is happening is this material is the soft iron equivalent for gravitomagnetism, but it's also the soft iron equivalent for the strong nuclear force. So it's this vibrating superconductor is like soft iron for all the forces. And one of the reasons I suspect this is in cold fusion you get nuclear transmutations without producing any radiation, and it's like a no-no. Everybody that's in the field said this can't possibly happen. And it's sort of like you're driving your car over a speed bump. When you hit that Coulombic potential wall, they call it, you hit the bump, you get a bang, and that's the sound wave would be equivalent to the gamma ray coming off. But if you were running blindly and taking big steps and you stepped over the speed bump, you would never know you passed over it. And so if this gravitomagnetic force can be amplified and have a longer range than the strong nuclear force, energy can be exchanged without producing radiation. So that's why I expect that the magnetic component of the strong nuclear force, that's called the spin-orbit force. It's similar in structure, again, to the gravitational force and the electromagnetic force, but it's of nuclear origin. But also, because it's a magnetic force, it is not conserved. And I think it's amplified and reaches beyond the Coulombic and produces nuclear transmutations by a long-range force that wasn't there before.
Oh, okay. So this could be something that could be harnessed to produce. So essentially, you'd be producing fusion types of energy, except without the radiation.
Yes. What it would do would be sort of like a compass, which it's a magnetic force. Magnetic force makes your compass flip. Tend to make nucleons flip. And when you flip them, that's a beta decay, and it would tend to make things progress in a course of action called beta decay. Then when you get so many beta decays, then you'd get an alpha. It would allow a new path for nuclear reactions to occur. Just like and when you're hearing the sound from your speaker, if somebody would have built a speaker and not put the soft iron magnet in, then it wouldn't have been any sound. And they put the speaker magnet in there, that increased the gravitational field, the magnetic force in that speaker by 10,000. And then we vibrate these superconductive disks. That increases the magnetic component of the strong nuclear force, the spin-orbit force, by a factor of maybe 10 to the 39th power, and allows these transmutations to progress smoothly without emitting radiation.
Okay. So that's yeah. I mean, these are.
So now what you're seeing,
ideas.
if you look at what we're doing now, we're learning how to control all the natural forces. Everything that we have today is based solely on the control of the electromagnetic force. We have no idea on how to control the gravitational force, and the nuclear force we do. We let things fall down. That's about our limit. And the nuclear force, we bang things together, but we have no way to control them. But now that we're understanding the mechanism to control them classically, it opens up tremendous possibilities for new technology.
Yeah, absolutely. Well, does this bring any experiments that come to mind for you? I mean, do you have any experiments that you've proposed to validate these concepts?
I've been doing experiments, but I have a limited budget, vibrating with radio waves, and I haven't gotten any anomalous energy or anomalous gravitational effects. But when I was down at the SPAF conference, this is on the web, I said that we need to use nanometer sizes, and Professor Miley, then you can hear it on the lecture, was using crystals as large as he can get it. And then it's becoming more and more apparent that small sizes, 50 nanometers to 10 nanometers, are the range that has to do with cold fusion experiments. And as more researchers are discovering this, they're getting energy. Miley's now using small nanometer-sized crystals. Edward Storms, he started using small nanometer-sized crystals, and that seems to facilitate the reaction. Now, Storm says it just increases the amount of hydrogen that's absorbed. There's more surface to absorb it, so we get more of an effect.
Oh, sure.
And I don't believe it. That's just the conventional thought. I think we have new physics here, and the physics requires that size to get the velocity of sound.
Because, the resonant frequencies that would produce.
Right.
Well, now, in terms of gravity modification, do you have any experimental ideas there? Or?
Well, one thing we have to do is if we wanted to follow my path, is really figure out how to construct a superconductor that we could get a sound wave going through it at 1 million meters per second, and that would call something called optical phonons. That's like a light hydrogen atom that's sort of stuck in there, hanging loose, so to speak, and then have another one hanging loose at a distance away, and then put radio waves on them to get them moving in concert. So even though those atoms aren't moving at 1,000,000 meters per second themselves, like the water doesn't move at doesn't move at the velocity of the wave, but the wave motion can be at that frequency. And nobody's following that lead or trying to do that. And that's a material science kind of thing, and it's very complex.
Oh, yeah.
It requires specialized people that may have expertise beyond mine.
Yeah, yeah. Well, and this is all stuff that you're covering in your book, right?
Yes. What I do in my book is I take this velocity that I've observed in the cold fusion and the gravitational anomaly, this 1,000,000 meters per second, and I produce the energy levels of the hydrogen atom, the energy and the frequency of the photon, and this thing called the amplitude of harmonic motion, which is the intensity of the spectral line. Some lines are dim, some lines are bright. And I do it from a classical analysis. That's a start. And that says now we understand why atoms jump, and they jump at points where the impedance matches, and that means they jump at points where the gravitomagnetism equals the electromagnetism. They have to jump all at once. So if let's say you're a rabbit, and you're going to jump, and you were a slinky rabbit, and then your head was attached by a spring. That spring would be like gravity. It's weak. So you jumped to the next line, and you jumped, and about 10 seconds later, here comes your head along the slinky rattling back and forth. So then you have another impact. So if the electrons jumped like that, they would have emit one photon, and then when the second part came, they'd have another photon of weaker intensity. But everything moves together. And there's mechanical waves, there's electrical waves, and that implies that the gravitomagnetism equals electromagnetism during the quantum jump. And now that we understand that, can we put an entire system into a state of quantum jump? And as you mentioned, the superconductor is a macroscopic quantum system. And can we put that macroscopic quantum system into a state of transition? And that's what I say, yes, we can, by vibrating it.
Wow. See, and this is amazing, amazing stuff. I'd like to thank you for joining us today. We're out of time for today, but I would definitely like to revisit this more with you in the future.
Yes, and keep an eye on the recent advances in cold fusion. I think the cold fusion is going to hit before the anti-gravity will, but it's the one and the same technology. There's not 100 new laws of physics. There's one new law of underlying physics underlying both of these processes, and when we understand one, it'll facilitate the development in the second.
Awesome. Well, thank you again.
Okay, thank you.